Alrighty, today this video is on naming ionic compounds. Now we've already done the puzzle activity, so you know where to get the charges. So this goes along with learning target 1.5. I can write formulas for ionic compounds using the charge of the ions. So the first thing I have to talk about is oxidation number. For right now, I am giving you the oxidation number. It's on the periodic table. Later we're going to go and we're going to talk about what these numbers are, how we get these numbers. But for right now, just look at the table. So, the rules. So the subscripts tell us how many atoms of the element there are. So if we have Na2S, that means we have 2 sodiums and 1 sulfur. So it looks something like that. So the subscript tells us how many of the elements there are. Now, the charges need to be equal. So the cation charge needs to equal the anion charge. Compounds are neutral, so they need to equal 0 when you add them up together. You need to put parentheses around polyatomic ions. The easy method is cross and drop. So we're going to go through some examples. This is a relatively short video. So the first thing that you guys need to do is write the symbol with the charges. So for lithium, we look on our periodic table. It is in the first group, so we know that the charge is +1. Now we look at chloride, symbol Cl. It's a halogen. We'll talk about these family names later, but all halogens have a -1 charge. Remember, we got these charges from the periodic table. Now, we need these 2 charges to equal out. So this first time, it's very simple. We have +1 and -1. When we add those 2 together, it equals 0. So that means we have 1 lithium and 1 chloride. So our answer is LiCl. So it's as simple as that when the charges are equal to one another. But the world is not perfect, so we sometimes have to do what's called the cross and drop method. So calcium, symbol is Ca. Now when we go to calcium, we find the oxidation number. We find the oxidation number to be +2. Bromide. Bromide's directly below chloride, so it's going to have a -1 charge. Now, what we're going to do is cross and drop. Because these charges do not equal, we need them to be balanced. If you want, you can try to balance it, but the easiest method is to take this 2, and this 2 is going to come over for this Br, and this 1 from the Br is going to go to the calcium. So we're left with CaBr2. We can double check our charges. We have 1 calcium, so there's +2. We have 2 bromines, so that's -1, -1. That equals 0, so we know that we are good. Here is our answer. Another one, magnesium sulfate. So we know that, make sure that you can see the magnesium sulfate. Yep. So we know that magnesium is Mg. The charge of magnesium is +2. Now for sulfate. Sulfate is not on the periodic table. These are one of those polyatomic ions, so we have to find this on our reference table. So we look right here at the reference table for the polyatomic ions, and they tell us the charge there. So the charge for sulfate is -2. So it's SO4 -2. Now those two plus 2 and a -2, those cancel each other out. They equal 0. So we can just write it as MgSO4 because the charges are equal to one another. Now let's look at aluminum oxide. So aluminum is going to have a charge of +3, oxide -2. We're going to do the cross and drop method again. Grab a different color. So this 3 is going to come down to the oxygen, and oxygen's 2 is going to come over to the aluminum. So we're left with Al2O3. And we can check our charges. We'll have a total of +6 over here. And we have 3 oxygens. So 3 times -2, we get -6, 0. So we know we're good. Next example, ammonium cyanide. Ammonium's one of those polyatomic ions. So we look on our polyatomic ion sheet. And we find it to be NH4 with a plus. NH4, charge of +1. Cyanide. Don't eat it, it'll kill you. Cn-1. Those charges equal one another, so we are left with NH4Cn. Alright, and that is how you write the formulas for ionic charges. Now I have you here, we are going to talk about going the other way. Learning target 1.6. Learning target 1.6 is I can correctly, learning target 1.6, I can correctly use the IUPAC rules to name binary ionic compounds. So this is going the other way. So the rules for that. The metal is going to go first. The non-metal is going to go second. Remember, our metal is going to be our cation. Our non-metal is going to be our anion. We're going to change the ending of the non-metal to "ide". However, if it's a polyatomic ion, we are not going to change the ending. So do not change the ending of a polyatomic ion. So let's do some examples. So the first example, Ba. Now we know that Ba is barium. We're just going to write barium. We know that barium has a charge of +2. So it's going to be a cation, it's the metal. Next we have the OH. Notice how the OH is in parentheses. Remember, if you think back to learning target 1.5 where we have to write the formulas, if it's polyatomic, we have to include parentheses. And we'll go over that in class again. So this will be barium hydroxide. Next we have sodium. So this is going to be Na, sodium. And the S is sulfur. So this is where we drop the ending of sulfur and add IDE. So it's going to be sulfide. Currently, Miss Mace needs to be let in the building, so I'm going to stop there, let her in. We can do this one in class.